I can do Jeff's part. No worries.
Excellent. Okay, excellent. So, as you might know, we will be doing today RPKI Zero to Hero, Resource Public Key Infrastructure. Very important topic, and we are all trying to increase the awareness. We are trying to help BGP security, Internet Global Routing Security, more awareness, and hopefully today's session will be helping all of us. We have here vendor folks, Juniper, Arista, Cisco, and Nokia. Not only configuration you will see, but also we will install 3 different route validators. So Routinator and NLnet Labs. So also we have Octo from Cloudflare, Octo validator, also RIPE validator. 3 different validators installment will be. As you can see on the screen, the attendee's name, really we worked a lot. So many people, as you can see, from vendors, from the regional internet registry site, right with us, and also validator tools. I think all existing ones now will be shown. In 2 hours we will do. That's why I need to start immediately. So please, also you can share your question in the chat window. We will be, if really time permits, we will be answering them. But let's start. Can you go back? Can you go to the next slide, please? Yeah. Here, first, we will start with the creating ROA and how it is easy, especially on the right website. You will see Nathalie will show us. After that, basically, another 2 validator we will see. 3 validator installment we will see. These will be with us for the RIPE. Alex from NLnet Labs will also install Routinator, and Luis from Cloudflare will install Octo. After that, when the validator set up, we will start showing you how it is easy to configure routers, creating session with the validators, and then showing the validated validation steps. So here, Melchior will start from Juniper, Greg from Nokia, Florian will show us Arista devices, and Vinay, also Jacob with us, they will show us Cisco devices. So we will start with the Nathalie. Nathalie, it's with you now. Can you start showing us the next slide, please? Yeah, go ahead.
So I'm super excited to be here. We are having a lot of viewers. Thank you all. At the end of the session, if we have time, we do Q&A, but there will also be a slide at the end with a lot of reference material. So you can, if the demo is going too quickly for you or you can't follow every step in the installation or configuration, we have some documents prepared for you so you can look it up afterwards as well. Now, RPKI is not new at all, actually. It is already quite old. It was identified as a problem in 1986. This is way back. But until 1999, 2000, not much actually happened. And then people started coming together in the IETF, Internet Engineering Task Force, to start writing things up. What should be fixed? How should we fix it? How should we move forward? So in 2003, NANOC, the American Network Operator Group, held a secure BGP workshop. That was quite interesting. It led to a lot of discussion and a lot of thoughts on how to secure BGP in a more pragmatic way. So then, in 2006, RPKI.net was a software tool for Ergun, and a PNIC, the regional internet registry, started working on RPKI. So this is already still 12 years ago, way back. And for a long time, nothing really happened. It was just there, out there in theory. It's quite hard to define best practices based on just a theory. So actual implementations were needed for RPKI to mature. And this is what we see happening today. So in the last year and a half, 2 years, we saw a lot of traction happening. And that also had to do with the history of IPv4 running out. So IP addresses became more valuable. So we saw also more routing hijacks. And all that triggered more discussion on how to move forward with RPKI. Today, the CyberOps working group is still very active in the Internet Engineering Task Force and is still working on updating RCs. Next slide, please.
Also, let's not forget many large-scale networks operators, they are deploying. Day by day, we are seeing announcements for the RPKI. Yeah.
Thank you, Orhan. So we hope you are next. And we hope you can help you with this webinar. And that's why the slogan we chose is Be the RPKI Hero, BGP needs you. At the end, we also have a slide with all our email addresses. It's always a good idea to email us any questions. No question is stupid. We're happy to help. And I say next slide, please. Yeah, oh yeah, the topology, very important. So what we have is the setup of RPKI, really quick, because I think a lot of you know this already. When you create a ROA, which I will demo later on, that ROA lands in a repository. And a repository is a big database together with all the other ROAs and other RPKI objects. And at the moment, there are a bunch of those repositories. And for example, with RIPE-NCC and Erin and EPNIC and LECNIC and EFRINIC. And all that data in those repositories, all those ROAs, they are collected by a validator tool. A validator is a piece of software that you have to install and run in your own network, because you're the boss of your own network, to make the routing decisions. Now, those validators, there's a bunch out there. Today we'll be demoing OctoRPKI, Routinator, and the RIPE-NCC validator. But there's also Fort, and there is RPKI client for OpenBSD. Those validator softwares, they plug into the routers. And so they feed the data into the routers, where the routers can make the actual routing decisions for BGP. So the validators basically say, is something cryptographically valid? Feed it to the routers, and then the routers match the BGP announcement with the list of ROAs to see, hey, is there a ROA that matches, a statement that matches, or do we see something else happening? If something else is happening, so there is a ROA, but the BGP state does not match that, then we consider that as a BGP RPKI invalid ROA, and it should be dropped. That is the goal of this webinar today, is to show you how to drop invalid BGP announcements. Next slide, please.
So we will not local preference decrease for the invalids. We will reject them. That's important, guys, rejecting the invalids, because I think we discussed before with Melchior actually, just decreasing the local pref as a policy in BGP policy for the invalids will not help you at all. So let's continue, and that's why in today our configuration on the routers will be rejecting invalid policy. Okay. Nathalie, it's your time again. Please show us how we can create ROA. I know it's really easy, especially RIPE website to do that. Let's see how you are defining this length, how basically we are creating ROA on the RIPE website step by step, please.
Yes, thank you. So my name is Nathalie again, and I will show you how to create your ROAs. A ROA stands for Route Origin Authorization, and it is a cryptographically signed statement about which AS number should originate which prefix. There are two ways to create a ROA. The first way is to use the user interface from your regional internet registry, like RIPE, LECNIC, EPNIC, Erin, EFRINIC. But if you prefer to run your own certificate authority and store your own keys, you can install a software package called Krill and create your own ROAs there. But today I will demo the RIPE-NCC member interface.
So, by the way, we cannot see the screen if you are sharing.
I will share my screen, yes.
Okay.
So I think now you should see the member portal of RIPE NCC, right? Yep.
Yes,
okay.
Correct.
Yeah. As the first step, you need to log in with your SSO account. And this is a single sign-on account that you can create yourself. My account is linked to 2 LAR accounts, as you can see. Oh. And today I will use the account for Melchior. When we go to the RPKI dashboard, under resources, you will see a couple of things for immediately. There are currently 2 BGP announcements. And these announcements are collected by RIPE NCC through their route collectors. So they have a bunch of route collectors all over the world that collect routes, feed in to this dashboard to show you what do we see being announced at the moment, specifically for you, for your LAR. So that here, if you look a little bit down in the BGP announcements, you see 2 announcements, one for a /22, one for a /24, and the current status is unknown. That means that there currently is no ROA for those prefixes. So let's change that, which is quite straightforward. As Orhan just said, we just tick the box and then hit the button, create ROAs for selected BGP announcements. It asks you to review and publish the changes. And if you click that, you will see that the 2 announcements go from unknown to valid. This is exactly what we want. We just verify, is this the announcement that we want to see? Is this announcement correct? If I agree and I want to create a ROA for these, I just hit the publish button. And here they are now valid.
If I want to change the subnet mask, I can also do from this window, right?
I'll get there, Orhan. Okay, so next. There is one more thing I would like to show, and that is the use of the max length. Because the max length attribute in a ROA defines what is the maximum prefix size that is allowed for this ROA to be valid in BGP. So for example, if we have this /22 here, this ROA now, if I go to ROA, you can see it a little bit better. This is the ROA I just created. It has a max length /22. And that means that you have to announce it as 1/22. If you announce more specific from that, that is being seen as RPKI BGP invalid because the max length is strict. It is good practice to set the max length exactly as how you are going to originate a prefix. So if you are only planning to announce that /22, create a max length of /22, which is the default. It is recommended if you plan to announce more specifics to create separately ROAs exactly matching those prefixes. So that is important. This is the most common thing that goes wrong when people create ROAs is that they make a mismatch in the prefix length. So that is max length is an important attribute, and be as specific as possible. I think that is the thing. If I want to create an additional ROA, that's quite straightforward as well. I just hit the blue button. Yeah, and it shows me a screen. I can fill in any AS number, a prefix that belongs to me. I cannot just hijack anybody's prefix. The interface will only allow a prefix that belongs to me. For example, this prefix does not belong to me, so I can't put it there. And here you can play with the max length as well. That concludes my demo. If you have any questions, my email address is on the slide later. Back to you, Orhan.
Yes, can you go back to agenda slide? I think now Thies will be next, and he will show us how. Okay, now we've seen how to create ROA, but we will start installing 3 different validators, as I told you. So RIPE, Routinator, and Octo. Next is, yes, please show us how to install RIPE validator. Now we will see the prefixes there from different regional intent registry, 5 regional intent registries we have, as you know. So we will see those entries in those. All validators actually, maybe different implementation, but at the end, number of states it will be almost same in all the validators. So can we start?
I will share the screen now.
Excellent.
And you will see yourself in the loop, I think. No.
Yeah.
Okay. So hi, I'm Thies from RIPE NCC, and today I will show you how to install the RIPE RPKI validator. The RIPE RPKI validator consists of 2 components, the validator and the RTI server. The validator retrieves the RPKI objects from the repositories over rsync and HTTPS, and the RTI server connects to the validator, gets the validated objects, and serves those to the routers over the RTR protocol. For this installation, I'll be following the installation instructions that we have on our GitHub page. We package the validator for CentOS, for Debian, as a Docker container, or for anything that runs Java. And because we're using an Ubuntu machine, I'm using the Debian packages. The installation consists of 3 steps. First, I download the packages and install them. Then I need to tweak the configuration a little bit. And then I start the validator. Let's go. So, as I mentioned, the first step is to download the packages and install them. I seem to have lost my focus of the screen here, so I need to copy the link again. So if you do a live demo, you need to be sure that you actually can copy something. Oh, okay, there it is. So I'm downloading the RTI server and the validator itself, and I will install those 2 packages. During this installation, the dependencies of the packages are also installed, and that includes Java and some other tools that I needed. After the package is installed, you need to adjust the configuration. By default, the validator and the RTI server listen only on local hosts, but because we want to connect to the validator from a router and we want to see the web interface, we need to adjust these settings. So for that, I'm going to adjust the settings for the validator, and instead of listening on localhost, I'll make it listen on 0000, and the settings for the RTI server, which needs to listen on 0000 for its web interface, and also for the RTI port. Now I've adjusted this configuration, so I can start systemd service for the RTI server and with the validator. Well, I enable them, then I start them. And let's check that they are actually running while checking the systemd log file. You see a bunch of output here, and that means that the validator is actually doing something. Okay. Now, when it's installed and it's listening, you can go to the web interface to the validator, and you may notice that there's only 4 trust anchors here. ARIN is missing. We cannot distribute the ARIN tall, so you have to download that yourself from the ARIN website in the RIPE validator format. For this, I need to download this file and upload it to the provided script. Okay, that output looks good. Now, when I look in the validator, you can see that there are 5 repositories here, and they are all pending. If I take a look at the monitoring of my backup instance, you can see that the validation run takes about 15 minutes. So in about 15 minutes, the validator should be ready, and it should have the new ROA that Nathalie just created. If I take a look at the backup instance itself, you see a validator that already has finished loading the ROAs, and you can see all the repositories that are there. And if you open a repository, you can see the amount of objects that come from there and the invalid objects. And for an invalid object, you can also see what validation errors or error occurred, and what error and where the object is from. So in which repository it's located. The validator can also show you the ROA, all the ROAs that it knows about. And in this case, I will look up the ROA that exists for a test range for which there are invalid announcements. So when we look up the test range, we see that there's a ROA for AS196615. But if we look at the BGP preview, which uses the BGP announcements seen by the routing information system, you see that there is an invalid announcement. And when we open that, you see that there's an announcement for AS12654, but that there's no ROA with the matching AS, but there's a ROA for this prefix. So this announcement is invalid. Yeah, this is my demo. Let's continue on with Routinator.
So thanks, Thies. What we've seen here, our install was required extra effort, it seems, and I am expecting same thing for the other validators as well. And I am basically wishing to hopefully see also Arin in the list and not extra step for this. So next, I think Luis will be showing us Octo, I think, right? So OctoRPKI, I think it should be.
I can show OctoRPKI, but I thought it was Routinator. I can.
Just a second. Let me see in the agenda. Actually, yes.
I could have been wrong.
Routinator will be Alex. Will show us Routinator.
Okay,
Alex, are you ready?
yeah, I can do that. I'll share my screen and I'll give you a demo of Routinator. Hi, my name is Alex. I work at the NLnet Labs. I will be demoing Routinator whilst I keep my cat out of the screen. I should do. There we go. All right. Can you all see this?
Yes, we can,
Yes.
Alex.
Okay, wonderful. So you saw that Thies installed RIPE-NCC validator from a Debian package, but Routinator, we develop it a lot with very frequent releases, and we decided not to do any packaging for it yet. So we're just going to build this from the source, which I'll be demoing live. That should be lots of fun. What Routinator needs in order to run, and that basically goes for all of the validators, is rsync. The rsync protocol was used, especially in the past, to fetch data from all of the different RPKI repositories and download them to your local machine in order to be validated. So that's one part it needs, and what Routinator also needs is a C toolchain. So those two elements I'm now going to install. So that's done here, with a bit of luck. And then the next thing that we're going to do is actually install Rust, because Rust is the language that Routinator was programmed in. So that is going to be my next step. There we go. So I'll paste in the next line. Basically, I'm downloading it from curl and then piping it to bash. I understand there's some security things there, but you know, I'm just going to go through the quick demo here. I'm going to proceed with the default installation, and it'll install all of the components in order to install Rust-based applications and using its packages. So that should be fairly quick and pretty easy to do. So I need to configure my current shell. So I do a source cargo env. There we go. And then the next step that we're going to do is just do a cargo install Routinator. It'll download all of the different dependencies that Routinator relies on, package them up and create the application. That'll take a bit of waiting. So in the meantime, I can tell you about the transition that we've made from using rsync to using HTTPS. Because more and more, you see that repositories support the so-called RRDP protocol, the RPKI Resource Delta protocol, which relies on HTTPS instead of rsync in order to download data. And the great thing about this is that you can use a content delivery network and that kind of thing in order to distribute the data, and it really decreases the load on all of the distributed systems. Because in the olden days with rsync, as the data set grows, in order for you to fetch data, the server needs to calculate the differences between what is on the server and what is on your client. And all of the RPKI repositories got hit more and more often as more and more people start installing RPKI validators and also fetching data more often. So what we see in the wild right now is that about 1,000 validators are installed in production worldwide, and they are hitting the repositories on a temporary basis. The RFC in the ITF says that you should fetch at least once an hour. That is something that is done by quite a number of organizations, but you see that the desire to get fresh data is pretty big, and it's actually quite reasonable right now to fetch data once every 15 minutes or once every 10 minutes. So that is also the default that Routinator has adopted now. If you start it up and you don't change anything in the configuration, it'll fetch every 10 minutes by default. When it does the very first run, it'll download 500 megabytes of data. All of the RPKI repositories combined contain 500 megabytes worth of ROAs. But in order to install an update or to fetch an update, it's usually only just a couple of kilobytes. So it's actually quite light once it has its initial data set. You can see that I now installed the package, and the next step is for me to initialize the application. Now, I do this by typing Routinator init. And the first thing it'll do is give me an error message, or at least a warning. As Tis just explained, Aaron does not allow the redistribution of their trust anchor locator completely freely. So you have to download, or you have to go to their website, read the terms and conditions, and if you agree to them, then you are allowed to download the file. It's an explicit thing that you do. But they also give the option to build this into your software application as long as it's a clear, non-ambiguous thing. It's in people's faces. And that is basically what the init command does. It says, look, you have to make a decision about the errand tile. If you want it, then you have to explicitly write that you accept the errand RPA, and then you're good to go. And that is provided that you read that PDF file with all of the terms and conditions. So I'm going to do a Routinator init accept errand RPA, and now it created the cache directory for me, where it's going to download all of the different ROAs and certificates and all of the cryptographic data. And it created 5 trust anchor locators for the 5 different regional internet registries. And the last thing I'm going to do for this demo is to start up Routinator, and I'm going to give it a -v, so it shows some verbose logging. I'm going to start it up as a server, and I'm going to enable the RTR server on port 8323, and I'm going to enable the HTTP server on port 8080. I'm going to fire it up, and the first thing that you'll see is that it connects to all of the different trust anchors and starts downloading data. This will take about 10 minutes, and after it's done, or whilst it's ongoing, you can see in the browser that if I go to the web interface, then it says that initial validation is still ongoing and I have to wait. So this is one that I installed earlier, and you can see that it already has a serial number. It downloaded all of the data for using rsync and the rest using HTTPS, and it currently already has some connections from routers. That's about it. That's all I wanted to demo.
So Alex, I want to ask a question. When you talk about actually rsync and RRDP, so
Yeah.
you said more and more we are now seeing RRDP. Was it because to reduce the repository load?
Yes. So basically with rsync, the server is involved in calculating the differences between what is on the client and the server. And if thousands of validators start doing that every couple of seconds, then that doesn't really scale very well across the entire internet. And yeah, the web nowadays is built around HTTP, and making something scalable like that is much better done using HTTP. So that is what everybody is now transitioning on. Fun fact, there are only 2 repositories left that rely completely on rsync. That's the one for LACNIC, and that is the one for JPNIC. If those 2 repositories update to RRDP, basically we could be running validation without rsync at all. By the way, in the meantime, initial validation has completed. So now I downloaded the 500 megabytes. The serial number is 0. And it will now send out a notification to routers that they can start fetching data over RTR. So Routinator is now ready to go. It's serving data to routers.
Now Routinator is ready as well. When we configure our routers, will we connect to your server as well?
Yeah, it's totally available. Yeah. So I guess now Louis is next.
Yes, Louis, please, can you show us Octo?
Yeah.
So from Cloudflare. Okay.
Yeah, I'll stop sharing my screen and off you go.
Thanks, Alex.
Thank you very much. Hi, everyone. So I'm Louis from Cloudflare, and I'll demo the installation of our validator, which is OctoRPKI. So I'm going to start sharing my screen in a second, and here you go. So what you have to know with our validator is it comes into 2 pieces, the validator part and the RTR server part. So the RTR server is the part that talks to your router. We chose this system to distribute. We put the Go RTR at the edge on our POPs, and it fetch a JSON file, which is produced by the validator. So we have this distributed model so that we are actually as close as possible to the router. And while we have the validator in a safe place that we monitor and keep an eye on. So the RTR server, the RTR part is very simple, very lightweight, so it can be embedded on the router. It can be put on the server. But here in this demo, I will put the validator and the RTR server on a single virtual machine. So both are available, both tools are available on github.com, cloudflare/GoRTR, and OctoRPKI is available on /RPKI. So you have multiple ways of installing it. I will show you the Debian package version. At the moment, we have 2 virtual machines. One is already running with the Docker version, but I will not expand on this. I will just demo the Debian packages. So let's start with GoRTR. So first, once you go into releases, you will get the Debian package. And on the machine, I will wget. Like I lost the connection. Okay, so I will wget the package and GoRTR. I will install it. And it's almost ready. The service is not started yet. I will start GoRTR right now. So by default, without a validator, it will connect on the Cloudflare JSON list that we provide on rpki.cloudflare.com. And this allows you to get started. Like if you want to run a test, get started very quickly. you can start with directly go RTR. It will be automatic and provide the RTR server on port 8283. So if I do JunOS you will see it has started, it has fetched the data, and it's ready, it's listening for connection. So now for the validator part, so it's the same thing. Let's download the release at the Debian file. And installing it as well. So just like it was said before, the ARIN requires a specific tile. It requires you to agree to the RPKI, the ARIN agreement, like the tile agreement, so the RPA. So you need to download it separately and paste it in. And so you go to the ARIN page and you need to paste it on the tile directory for the validator to work with. So at the moment, the OctoRPKI only supports up to this version. It doesn't support the latest version with the rsync URL. So you need to use this version. So I download the ARIN tile. I will put it into the user share OctoRPKI tiles ARIN.tile. And by default, OctoRPKI is configured to read this whole directory and use all the tiles readily available. So you can list in the directory, you have all the tiles. So now I need to pass a special argument since we're running the GoRTR and the validator on the same machine. I will just ask OctoRPKI to listen on a different port, and I'm passing arguments into the OctoRPKI config, which is in etc default OctoRPKI, and I choose not to sign the output file. So now we are ready to start OctoRPKI. So systemctl start OctoRPKI, and we can see it's already synchronizing. It's fetching the rsync and the RDP repositories. So both those tools provide Prometheus endpoints, so you can visualize the state of the validation. So an example is with the other version running, you can see how many ROAs you have on the RTR part, how many connected clients, when, and for the validator part, when was the last validation, how many ROAs per registry. And while it's fetching the initial state, we ask now GoRTR to connect to to OctoRPKI. So we pass a same config, which is in etc default GoRTR. So since we did not set up the validation of the JSON file, we just disable it, and we indicate the path, the JSON output produced by the validator. So now that we have this configuration, we can restart. And we will see it's restarted. And at the moment, it's not the output.json is not available because it's still fetching. But once it's ready, this will refresh and you will have all your ROAs available. So you can track, and I will refresh currently, and you should have, it should collect soon, at least, the output of the validator, and well, it doesn't seem to be available right now. And you're good to go. Now you just have to configure your routers to GoRTR and on the port 8283.
Guys, I think Luis, it's done as well. It's really in 30-35 minutes. we install 3 validators. It is really easy. And meanwhile, by the way, we have been discussing some technical things. Now, actually, thanks for showing this, Luis. I am sure we have some documentation how to install step-by-step installation guide type of documentation, right? Excellent. Yes. So before we start configuring the routers, Melchior will start. I think there are a couple questions. Very fast, let me read the question and also get the answer. Nathalie, I will also want to discuss just one of them, one of this question with you. I want to ask a specific question to you, please. First one, this is important because people might confuse. High panel, do we need to include our downstream ASs in ROA? Basically, no, because you only need to include your origin AS, not the downstream AS. Every AS, they will create a ROA for the prefixes from their autonomous system, not downstream, upstream, which actually brings me to our discussion. I have a video on my YouTube channel or YouTube channel with Melchior. We discussed ASCON approach for the PET validation. Actually, he wrote that draft. There are different things, but we are talking today origin validation, specifically RPKI. So definitely, when you create a ROA, you need to create it for your own prefixes, for your own AS, not downstream. Another question, this one I want to discuss with Nathalie, please. Can we create ROA for a prefix that can be announced by more than one ASN in case of DR, DOS redirection, etc.? Multiple ASNs are allowed, but is there any limit, Nathalie? What's the procedure if we will create the ROA for multiple ASNs?
Yeah, no, that works. Yeah, ROAs can overlap, and also ROAs can have different ASN, but you have to create a different ROA, so a different statement, basically, for every prefix if you have different ASNs. So if you have prefix /24 with ASN 1, you have to create that ROA and a separate ROA for the same prefix ASN 2.
Okay, this one was nice. By the way, we have 3 validators shown today, and there was also a question, which ones, based on the statistics, most of them are used. I think Routinator a little bit more than the others. If I want to use more than one validator, and I think for redundancy, I should use 2 at least. But is there a reason to use 3 of them? What do you think, Nathalie?
Well, I would ask the validator people, but for redundancy, I would pick two different ones. That is
I will discuss this with Melchior as well. Thanks, Nathalie, for the answer. Melchior, are you ready?
Yeah, I am.
Excellent. So let's start.
Let me share my screen. So you should see my terminal now.
Yes.
Which is logged into so by the way, I'm Melchior Aelmans. I work with Juniper Networks. And so I'll be demoing how to configure RPKI Origin Validation on a Juniper router. In this case, it's a virtual MX. And as you can see, we only have a very basic configuration today we're going to start with. So we have configured a BGP with one neighbor. So let me show you actually the configuration, how it is done. Actually, the configuration of the validators is really easy. So we configure a group, or in this case, 3 groups and 3 validators. And then we commit that configuration. And as the validators are already set up, we will immediately see validated ROA payloads coming in. So this will take some time to get them all in. Oh, there, this is finished now. So let us continue configuring some policy. And I'll copy paste that in right now. This is quite a lot. So let me change the output a little bit. So what we'll be doing is now that we have the database filled, the RPKI database, we create a policy which takes actions based on the validation state. So if we start at the top, we see a term which is called valid. So if we receive a BGP announcement that matches against a valid ROA, then of course we will accept it. The second term is called invalid. Basically what we want to do, and that is what we discussed, Orhan, Jeff, and I in another webinar 3 weeks ago, is that we want to reject invalid announcements. So we have a policy that if a BGP announcement matches or doesn't match with an existing ROA, then we reject it. That could be invalid ASN, so invalid origin ASN, or incorrect max length. And the third term is unknown. Unfortunately, there are still quite a lot of routes that are not covered by a ROA, but as we do need those routes, we will accept them. And the last 3 lines you'll see is basically creating the communities so we can also tag the routes. Now that we have a policy, we of course need to apply that policy to our BGP session, and that is basically this last comment I just entered. So that basically says now apply the policy we just created to our BGP session, and it's called an import policy called validation. So if we commit that, then now if we do a run show route, and I'll use this route, for example, you see that it has a validation state of valid. And of course, we can also do run show validation database. And you see all the ROAs. If you do a run show route validation state invalid, for example, that's probably going to be empty, as we were rejecting all invalid routes. And if we do a valid, we of course get a whole bunch of routes. So basically, everything we need to configure in order to enable RPKI origin validation on a Juniper router is basically what you see on the screen here. And so that's it for Juniper.
These are all the steps to basically enable RPKI on the Juniper router. But
yeah, exactly.
It was very fast. So it was very fast. What we will do now? So we are going basically ahead of time. I think a couple things we can discuss. We have more time than we planned. No worries. So for the same question, Melchior. At the moment, and other vendors also will configure those 3 sessions. So why 3? Why not 2? Or let's say, why even 2? For redundancy, what else do you think?
Also, in this case, I configured 3 sessions because, of course, I wanted to see if all 3 validators were working. But yeah, as Nathalie was saying, my advice would be to at least have 2 validators, of course, configured for redundancy reasons. 3 could be more redundant, but then 2 would be enough.
Melchior, what happens when you receive conflicting information from different servers?
That's a very good question. It came from the White House, I see. Nice background, Jeff. So it depends a little bit per BGP implementation. So the answer could be different for Cisco, Arista, Nokia, and Juniper. Unfortunately, there's no serial attached with the ROA, so you cannot really sort of decide which one is the best one or the latest one. So there's no real clear answer to that. The good thing is, however, that it's that you should not receive different output from different validators because the input is the same. right? So all the 3 validators, or in general, all validators get their data from the IRRs. So it would be really strange if the output would be different.
I can tell you what happens on Cisco.
Yeah, and I can.
On the Cisco, each one a prefix is validated if any ROA exists to make a prefix valid, then it will be valid. So if the ROA is received from one particular validator but not the other one, then the prefix will be valid. So if there's any ROA from any validator, it will be valid, and that's the way that it's written
good
up.
to be
now,
on the safe side, I think. It's good.
Now that's the right way to do it. Now when ROAs are being updated, they can be updated at different times. So you can get transient periods of several minutes where you have different ROAs being received from different validators. So they can be out of sync for many seconds and maybe even minutes. And during that time, we have to make allowances in the code for that to happen. And so therefore, if there's even a single ROA from any validator that will validate a prefix, that prefix will be valid. So there's no problem.
Looking at JunOS configuration, I would think that it depends on order of policies created. So in your case, you were allowing before denying. So if you have both, you will probably permit one to get in, right?
Yeah, and it could be also totally opposite. So if I see somehow, I could deny in the first place, but you wouldn't be on the safe side, I think. So yeah.
So yeah,
if there's at least one ROA to validate, it's valid. It's valid.
Yeah, I can. It's the same on the Arista side. So the moment you have multiple validators and you have one valid ROA, the prefix will be deemed valid.
And next, actually, let's continue with the next demo. I think it will be Florian, Arista. Am I correct, or Greg?
Correct. It's Greg.
Greg, okay. So please, Greg, share with us Nokia, how we are configuring the routers, and then so far, really, all the validators as well as the routers, just 5-10 minutes, maybe even less time. Even creating ROA, it probably took a couple minutes only. So it is easy steps. And for the validators, I should say, if I am not familiar with maybe Linux, etc., step-by-step guides, all of them have. So it can help us anyway. Okay.
Okay, thanks, Orhan. My name is Greg Hankins. I'm a product manager with Nokia, and I'm going to show you how to configure origin validation on a Nokia router real quick. I'll just show you our basic setup. I have 2 BGP peers configured with full v4 and v6 routes. And then we also have, obviously, no RPKI sessions, and also the database is empty. So I'm just going to go and load a configuration. I have a pre-configured configuration that I'm just going to load, and then I'll show you what it does. So all of the configurations do similar what Melchior was explaining. So I'll just explain a couple differences, but all the steps are the same: setting a policy, setting a community, and then setting up the validator. So we create the extended communities here, and then next we create the policy. Now I'm doing something a little bit different. I'm going to accept invalids. This is just a troubleshooting step that I'm doing. Obviously, we want to reject invalids at the end, and we have a separate path selection configuration that we'll use to do that. But the goal is to reject invalids because it's known invalid routing information. So there's really no good reason to accept it. So we're going to set different local preferences based on the origin validation state. So just do that here. And then we're going to apply our best path selection. We're going to make sure that we use the origin validation state in our best path selection. And then we're going to tell the router to just reject invalid state anyways. And then it doesn't matter what the policy does. We're going to turn on origin validations for v4 and v6. Then we'll apply the policy. And the last step is just to configure the 3 validators. So we've done that. And now we'll just show you how how fast it loads. I've configured the 3 RPKI sessions. And you can see they've started to load. And this is actually a router in New York talking to servers in Amsterdam. So within about 20 or 30 seconds, it's fully loaded. And then we can show you some information. So I'll show you the database summary. And you can see that they're still loading. We're just, okay, there we go. Now they're almost fully loaded. So that's very nice. And then we can also see some origin AS information. So we'll look for this AS, which is 34562. This is the AS that Nathalie configured at the beginning of the demo. And we can see that we've already gotten this prefix, which she signed at the beginning of the demo in the database, and it's valid now. So we could also look at the prefix directly. If you wanted to do that, you could do 45, 141, 0, and then you can see that it's also in the database. So now I'll just show you real quick how you can see that the local preference and the policy is actually being applied. Remember, I set it to 100 for unknown, 110 for valid, and 90 for invalid. So you can see there's no 90s because they're being rejected by that best path selection knob. There's a whole bunch of 100s that are invalid and a couple of 110s that are actually valid. So let's look at the specific details for that route, which is 45, 141 at 16 minutes. And you can see that before, these are the original attributes. It comes with a local pref of 900, and the origin state is not found. That's what we're getting from our IBGP peer. And then after we apply the policies and run it through BGP route selection, you can see that the local pref is 110, which is valid. We've added that extended community that we set, and you can see that the origin validation state is now valid. So a couple more show commands. If you wanted to see the different states, so we can look at all the different states for origin validation. So let's just look at all the invalids. This is a step I added for troubleshooting. In case you just wanted to see how many invalids you're getting, you can see there's quite a lot. And actually, if we just run it through, if we disable pagination and just let the router run the command, you'll see that there are actually about 4,000 IPv4 invalids and about 450 IPv6 invalids. So that's a good indication that there is quite a bit of invalid information in the routing table. And it's probably a good idea to turn on origin validation because you're gonna remove a significant amount of invalid routing information that you don't want in your routing table. That's all I had.
Okay, thanks, Greg. Basically, these guys are very easy. I am now thinking we really took a lot of risk. These are live demos, both validator people and also vendors. They are doing live demo, and we are seeing it just works and very fast. I think it was around 133,000 prefixes we are seeing, and global routing table for IPv4 unicast, I think around 800,000. So it makes more than like 15% of the prefixes. I think now we have ROA, right? So, and increasing. There is one question before we move to Arista configuration. By the way, time-wise, we are going well, and I like some questions. Many questions are good, but some of them are very long. That's why I'm not reading them. Alex, maybe we can discuss this question with you. You answered that, but also for the live audience, also we will be sharing this recording on YouTube channels, RIPE, Orhan YouTube channel, etc. We will be sharing, so later on people can see. Any config needed on validators to accept sessions from routers? Basically, after you, also we can discuss with Thies and Luis as well.
Yeah, so by default, if you start up the session, the RTR session on a certain port, it will just accept all connections from all IP addresses. Of course, it is possible to lock this down with a firewall configuration or access control list or something like that. But there's no configuration needed on the validator itself in order to make that work. It'll just accept connections from everyone. We've seen configurations with RPKI validators accepting up to like 100 router connections to a single validator instance. No problem at all.
And then we don't need authentication before session come up, etc.
No.
You don't need it.
No.
Okay. And I think same thing for you, Thies and Luis, right? So for other validators, Thies, are you there?
Yeah, I'm there.
So anything needed from the validator side? Like
No.
authentication? No, right?
You can set up authentication, but it's external. And optionally, of course, you can firewall it, especially our HTTP interface. You do not want it to be available from the internet because it has an API that everybody can use. But in practice, the RTI server, I think you should firewall it, but there's no configuration needed to open it up.
Yeah.
And when we looked at configuration of the routers, you could see no additional parameters to provide authentication or any kind of firewalling were provided. So you could derive from it that you can just configure a session and it will get established if you do nothing else.
Okay. So how you are doing that background, Jeff, by the way? It's nice. Every time I have seen different things. Okay, so next we will discuss Arista. Florian will be showing us how we can configure RPKI on the Arista routers.
Thanks, Orhan. Yeah, so my name is Florian Hibler with Arista Networks, and I'm gonna show you how to implement RPKI Origin Validation on EOS. So first of all, same as Greg, I'm having a full table in our lab. So what we essentially gonna do is configure a route map, which then does a local pref for valid prefixes, changing it up, dropping invalid prefixes, and leaving it for unknown. That means no ROAs existent. As it has been mentioned a couple of times, the rejecting part is really important for your internet edge security. So then I would say, let's go ahead. I prepared a bit of configuration here. So as I said, what I'm essentially gonna do is creating a route map, matching on OriginAS validity, saying it is valid. The same for not found, and in the end, then dropping the invalid ones. That's just the route map. We don't have any RPKI validators configured yet, as we can see here. So no cache servers are configured as of now. This is what we're gonna change now. So we're gonna go for inside the router BGP context and start configuring the route caches. We're configuring all 3 route caches. And that just means it's enabling a connection towards the validators. We also want to enable the origin validation itself. This is something I am doing now. So we have multiple options here as well. First of all, for how we want to proceed with eBGP neighbors, IBGP neighbors, redistributed ones. So in our case, full table is eBGP. We will do use the local ROA database for IBGP routes, which we're gonna send towards our internal network. We will actually want to attach the origin validation state as an extended community. That's essentially the full configuration. We're committing it. It's starting RPKI. And we can see we're successfully connected to all 3 cache servers. just to verify, same command as before. We can see connection is active on all 3 of them. We're in the mode syncing. That takes a while. In the meantime, we can see if we already learned some ROAs. Not yet. That will pick up soon. Already see we're learning something here, and the total number is populated at the end. To give you an idea how it will look in the show command, if you're looking at a valid or invalid prefix, you will see once you configured RPKI, this particular one, AS origin not validated. In this case, we're still learning the ROAs, so we don't have a state yet. Let's see where we are, still learning. The moment we have learned the ROAs, it's being processed in the system, and we're matching against the AS origin validation, the AS, well, we're matching the prefixes against the ROAs. So, yeah, it still takes some time. Please note that this is not running on a physical appliance. This is running on a virtual appliance. So it might take some more time. Should have everything soon. Yes. Yeah, that looks good now. Yeah, we're still in syncing state. Yeah, and there we are. So we matched against the ROAs. We see slight difference here. And this is essentially what Alex and Jeff mentioned earlier on. Alex and Jacob, because you can have different sync intervals on the validators. So one validator might actually give you slight more or less ROAs. This should catch up within probably 5 minutes. I think 600 seconds is the default on the ROA refresh time on the validators. So let's see if, yeah, BGP is still processing the ROAs now. In the meantime, what we also doing with, as I said, this particular comment, so we eBGP, we're processing locally. iBGP, we're adding the extended community for origin validation state. To accept it on a neighbor, we would need to also say iBGP community instead of send. That way, we would use the RPKI state origin state validation to accept drop or, well, to flag the prefixes accordingly. And there we are, it's done now. So we see origin validation for 1.1.1.0/24 is now valid. So you can also have a look how many prefixes, for example, are invalid. Let's see. And there we would then see that in the show iBGP state, we do see an additional field here, which either lists them as valid, invalid, or unknown. And this is just stated in front of the prefix. So that is my demo.
Florian.
Back to you.
Florian. Also, Alex, this one, I want to discuss something here with probably both of you. Alex said when the validator first time download from the repository, it was around 500 megabytes. It was taking, right, space?
Yes.
Yeah.
But that is signed cryptographic data.
Exactly.
All certificate, all ROAs, all certificate revocation lists, all manifests. So that is the heavy part. But what the RPKI validator does is validate all of that information and basically produce a flat text file of AS prefix max length. Just the text file, nothing else. And that is what it feeds to the routers. So all of the heavy lifting is offloaded from the router to an external device. And what the router receives is a tiny bit of information. It's just a flat text file with a list of prefixes, ASs, and max lengths.
Which makes adoption of RPKI actually going on. And that's what made BGP-SEC so complex, right? We've completely offloaded all security validation and all heavy lifting that requires crypto operations of box. Yeah. So it's all done on the server.
Definitely not feeding 500 megabytes of data to your router. It's just a tiny text file.
Yes, exactly. And what Jeff was saying, it was important. There was a question basically triggered me to start this discussion. So when we have, let's say, instead of 2 validators for redundancy, if we would have 3, let's say, and will it be 500? Of course not. So all the heavy lifting like decrypto and validation is done by the external server, not by your routers. Let's understand this. But, and that's why actually RPKI, we call it offline cryptography. BGP-SEC, which Jeff was mentioning, we discussed, by the way, BGP-SEC and other PET validation mechanisms with Melchior also on Orhan Ergun YouTube channel, you can watch. Online cryptography method. That's why it's much burden for sure for the routers, not the RPKI, not today what we discussed.
But can I add one thing to this? So you have to also keep in mind that you go like, oh, we're talking about heavy lifting here, but RPKI validation is not time sensitive. So because it does a validation run every 10 minutes, it basically has 10 minutes to go through its entire data set. So that also means that you can basically run these validators on a Raspberry Pi with like 2 cores. It's fine. If it has like 4 gigs of memory or 2 or 4, something like that, and a couple of cores, it has enough time to go through its data set to perform the validation in order for it to be finished in order to start the next run. So you don't have to think about provisioning your servers to run your validation on as like these giant boxes that need like 6 cores and 8 gigs of memory and lots of SSD space, because it's really not like that. Disk space will grow. It's currently 500 megabytes, and you have to imagine that 20% of all BGP is covered. So if we cover the other 80%, we're going to end up with a lot more disk space. But what it needs in terms of memory footprint and and CPU processing power, it's really not that much. Don't overspec your servers for the validators. It's really not necessary.
Maybe 4 or 5 gig, that would be probably enough for, because I think he's also calculating 823,000 prefix we've seen, by the way. I remember Florian output. So by the way, that's also another discussion. Why 823,000? If we would look at from another looking glass, we would see different maybe numbers. If you are deploying RPKI, if you are not deploying RPKI, there will be some even differences between what you are seeing in this AS, number of IPv4 global, IPv4 prefixes, etc. But this question, Alex, 3 validator on router. Let's say if I set up this session and 133,000 prefixes at the moment I am seeing, approximately how much extra memory usage it will cost?
But that is a question for the router vendors. So what is the memory footprint impact of each router?
Sure. Florian, maybe.
That is a very good question. I could only tell you how much I use right now. But yeah, very good question, as I said. Probably, I don't know, Melchior.
So, but I think
I've just looked it up. I'm currently using with 3 validator sessions configured, 70 megabytes of memory.
3 of them.
Yeah. So I have 3 the 3 sessions still configured. So I have in total 467,000 RV records, which results in 143,000 prefix entries, blah, blah, blah. And that results into 70 megabytes of memory utilization.
Yeah, I can chime in. For me, it's like 75.
Okay, 75 from 3 validators, and as of 2020, when we receive from each validator around 140,000 prefix and 140,000 ROAs, by the way, is around 15-20% of 800,000. So even if it increases, it's not much a job, too much work for the validators, and not at all for the routers itself. Actually, instead of 3, even if you configure it 5 different validators, it wouldn't be a problem. But generally, I mean, this is not problem at all, even number of session wise. It generally is a design rule. I tell people 2 is company, 3 is crowded, so 2 is enough for redundancy. But anyway, it's your preference. Next, we have Cisco. We will see RPKI configuration on Cisco routers. We have actually Jacob and Vinay, who will be doing this demo, guys.
Yeah, hi. So I'm Jacob Height. So I've worked on the RPKI on Cisco XR for some time. However, Vinay has recently been working more on it than I have. And so Vinay has prepared a demo, so he will take it away. Go, Vinay.
And thanks, Jacob. Thanks, guys. Yeah. Yes, I'll go ahead. Yeah, I just want to share the screen. Can you see the screen now?
Yes.
Okay, thank you. So basically, I will try to show some of the basic things with RPKI on Cisco routers. So we are using the XRv9. So I'll try to connect to the validators that were configured in the session earlier. So as you can see, there's no RPKI server right now configured. So we'll go into the config router and router BGP. I'm using this router BGP here, IDS number and stuff. So if I can show the commands that will be configured. So basically we need to configure simple configuration like this. So basically it's going to be a server IP address that we need to know. So I'm using these 2 IP addresses, and the transport is either, in this case, it's a plain text transport TCP with the 83.22.3. We also support the SSH transport also for the connection here, which would require username and password for the this thing. So I'm going to just configure that here, and then I'll commit it. And we can see the summary here. I think that right now it's not established. It will take a little bit extra. It's established now, and you can see all the ROAs are learned here, and we can also do a little more detailed output like this, which shows the server and the details of everything here. It's in established state right now, and on the 747. So the same thing. So I think we have all downloaded all the ROAs here, and for IPv4 and v6. This is the one we were using for the Routinator, which was set up earlier. I will try to use a little bit of a different topology now. To basically go over a few more steps actually. So I was thinking, we were thinking of using this kind of a topology here. So basically we have a Routinator here, which is going to give all the ROAs for us. And then we have this topology where we have a XRv9K here talking to an external BGP neighbor here, and then talking to one more internal BGP neighbor here. So that way we will. I want to show like when this outside node actually sends us a invalid prefix, we compare that with the ROA and how we reject it and as invalid, and how we drop it. And in other cases, how we can control the best path, the calculation also, depending on the validity of the state, the validity of the states. Let me just share that one.
And it will send the extended community in the IBGP.
Yeah. So I'm just showing the three boxes here. So this is the EBGP, which is basically talking to the Routinator, and this is the box which is talking to the, which is the peer ASR XRV9K, which is talking EBGP with the box here, and this is the one which is going to send the invalid prefix to us. So I just added the invalid prefix over here, so that here, this is one of the invalid prefix that is being sent here. So this will send a prefix of 136.0.0/16 with the AS number of 1, which is going to be invalid prefix, and our router will detect it and drop it and things like that. And also I will see that it will not be used in case when the best path, actually there's no other option, but the only one there, we still will drop it actually. So, and this is the other internal peer, which we are going to display the advertisement. So I'll start with the, so we can see the summary here for the this thing. So we have one Routinator connected here, and I can show you the details of the testing here. So we have like around 133K. So we have this here, and then we can see the details corresponding to the refresh time, response time, and the purge time, and other things like that. And also we can so this shows the RPKI table that has been downloaded from the Routinators now. We can see all the details of them. And the same thing for YV6 also, we can see them. So this is the one which is downloaded from the Routinators, and they're in the database right now. And then we can show you the, so this is a simple configuration that we have. So we are talking to two neighbors here. And right now there's nothing configured for validity and other things like that. So because nothing is configured, the invalid prefixes are used actually. So they are used in the best path calculation, and also they're sent to the neighbors and stuff like that. So if you see like this one here, so see the prefix here. So you can see this is the one which is downloaded from the Routinators now. This is the actual correct one. And if you see the output here, so we can see this is the one which we learned from our peer, which is invalid actually, but it is still being used in the best path calculation now, because we have not configured any of the validity checks and things like that according to the RFC. So that is what we have here. And then when we configure the validity checks and stuff like that, so then we can actually start doing the implementing the validity things like.
Reject invalid, please.
Yeah. So this shows the validity right now. And if you see here, these things are all disabled right now because we have not configured any configuration for the ROAs and the things like that right now. I mean, we are only connected to the Routinator for downloading the ROAs, but we are not actually using it in the best path calculation and advertisement and everything like that. So that's one thing. Unless the operator goes and configures those configuration, we will not start using them. So I'll show you what the configuration that we configure basically. So this is what we configure. So this is basically showing like we configure the origin validation enable. So which basically says that we need to start using the validation ROAs and stuff like that now. And also this will say that we can signal the extended community to the internal neighbors and stuff like that. So that is done now. And if you see in the,
so we have to enable it because we can enable it in different VRFs as well. So we need to enable it in a specific VRF that we're using.
Yeah. And if you see it here now, like we can see that this one is now actually marked as invalid right now because now we enabled the validity checks and stuff on different, we can control the where we enable it on the VRFs or on the neighbors. And so it's right now marked as invalid because we started configuring the validation states as per the RFCs. And then we will see also that we are not sending it out in the best path calculation to the peer actually. If you see on the peer now, we will, yeah, we are sending it out, but because we are not actually marking not to be used in the best path calculation right now. So if I add the configuration for that, in the configuration, I can add like basically saying we can use the validity checks in your best path calculation also. So now actually we'll start, we'll not send them anymore actually, if you see here. So that will not be sent out to the peer also. So even in the case of our network now, so this is like, we are learned it from the peer, but since it's invalid right now, it's not being considered as a best path. So we are just storing it and not advertising it to anybody. So that's how it is now. So we have the control of now, like basically saying whether we want to use the validity check state and also whether to send them out or not, and also to whether to use them as a best path calculation now. So just going over the configuration that we did now. So basically, this is the servers, cache servers we talked about. And then we have the origin validity configured here, which basically says in the global table now, right now we want to use the validity checks. And this will say like, we want to use the validity checks again. And for the best path calculation, we want to use this one. That's what it's saying. And this is saying that we want to signal the for the internal neighbors also, whether the external community is present or not. So that's what it is showing it. And if you can see here, we can see the so that prefix is not learned over here now. And also we have one configuration which basically says that in some cases, maybe we want to allow the invalid states also. That's what I wanted to show here. Basically, you can say some cases the operator wants to force a invalid also to be used in case of the best path calculation. We can do that. And then we can basically say like, so it's going to be used now in the best path calculation now, but it will still be marked as invalid, but it will still be used in the best path calculation now. So in the sense, like if you see the community being sent out, it will say actually it's invalid, but it is still sent out so that the controller and the operator can control in a way that he wants it. So it is being signaled here, and it's still said as invalid, but she's being used in the best path calculation still. Other than that, actually, we also have some configurations where we can add the prefixes for saying like mark it as valid forcefully. That's also other option that can be done by the operator now. So those are different options we have. Let me just show that one for quickly to complete the demo. So we can say like this, and we can in the ROAs now, we can configure a thing called as so RPKI route, that whatever we were saying, we can mark it as like a valid route. Right now, for example, if you have any lag or something in learning about the ROAs, we can do this way. So that way we can, so that way now it's not labeled as invalid anymore, and it's also being used in the best path calculation. And if you see on the peer now, so you can see it is marked as valid now, and that way you can control. You have the full control over the validity of the states now, and depending on what the use cases are.
So this is a manually configured row on the router that is not imported from the server. Right.
Yeah, and other thing is like we can do the VRFs and stuff like that also here, and we have the netconf yang and other.
And the route policy, about the route policy, the test for the
right.
invalid.
Yeah, let me show
local preference.
Yeah, let me show the route policy here. So the validation state can be used in the states checking for the policy now. So in the case we have the validation state in the statements here, we can use in the policy statements. So we can drop or anything like that. So we have the invalid state, and then we have the valid state, which is when the ROAs are matching the prefixes. And if it is not found, then we come here in this case. And also we have the case of not found is also another state we have. I think otherwise we can actually do the things called like disabled state also we can check actually. So that's how it is done.
So disabled state is when the routing, when validation is not enabled in that WRF, then it's disabled. When validation is enabled, but it's not found, then it's not found. So not found and disabled are different.
So not found, unknown. Okay.
So there is no unknown state. The state's called not found. Not found means that validation is enabled, but it's not found in the database. Disabled means validation is not happening.
Good. Can we see how many invalids at the moment we are seeing?
Yeah, I can show you. So right now, I think I have marked at the invalid one. I just had one invalid actually, because that one is being marked as valid right now. Because I can go to the one with the in the other one. We can do that there. We can do in the demo network. We had that, so that one we can do it here. So yeah, here we see a lot of this.
So while you are showing it, there are two questions that are IOSXR related. One of them is, you've shown only 2 RTR connections. Is there a limit? Can you do more? Why 2? Question
Yeah,
number
we can do more. Yeah, we can do more. Actually, I did not do that because for some reason the connection is not going through in this case, and that's why. But as we can show, the invalid and not found and the valid states are shown here, so we can do that way. Yeah.
Question number 2, whether you can make connection to RTR server VRF aware. So not from management VRF.
Connection to the RPKI cache today, I think, is global today. But we can apply the RPKI validity states on VRF and global, both actually, yeah.
Thank you.
So you can run the internet in a WRF and validate it in the WRF. But the server is connected through the default VRF.
Yeah, so I think the question was with regards to reachability of the server itself.
Yeah, just last I think just to the validity state this thing. So just for showing it, I can show the RPKI route policy here. Okay, it's not happening. Okay, I think I can just show it in the document here. So basically, this one just shows the validity state. Basically, we have the invalid, not found, and valid. And this is the case for the disabled. So I think this hopefully this is more clear now. So I think yeah, this is also shows the simple configuration that we use. So to explain cache server here, and then the prefix we can mark as a ROA on the box. Validity being used. Yeah, and also we have the netconf YAG right now for the monitoring and stuff, and also telemetry support is also present in the on the box for XIV9K. And I think that should complete my demo.
Thank you very much for that. By the way, can anyone say how many invalid prefixes at the moment we are seeing? Around hundreds of them, right? So if I think hundreds of them already there. So there is a question, in fact, valid question I want to talk about a little bit. Alex, you already answered. I've seen that. Maybe here we can also discuss about that.
There's 5,820.
5,820 invalid prefixes.
Invalid prefixes.
Yes, and why this is too much? Actually, good question. So there might be, of course, hijacks there, maybe subprefix, exact prefix hijack, but many times we are seeing also this max length field is used wrongly. Can we talk about this max length field? Nathalie, we can talk also on this, Alex. So because when you create on RIPE database, this ROA, you mentioned, Nathalie, about the max length field. And I think this is very important field and people are using wrongly, and that's why most of them, not maybe most, but a lot of invalids prefixes we are seeing. Can we talk about this? Nathalie, maybe you can start.
Yes, very short, because we're wrapping up this session. This will be the last question, Orhan. Florian is ready to put his slides up. So the max length field is indeed the field that causes the most problems in ROAs when people create them, because they don't understand the use for the max length field. So that is why we recommend to set the max length strict. So put the max length exactly the same size as that you're originating. Otherwise you end up with problems, or your prefixes might get dropped as they become BGP invalid. I think that answers your question.
Yeah, thank you very much for this. By the way, in much less than 2 hours, we finished 3 validator installment and 4 router configuration. Routers basically connected to 3 different validators and got 130,000 prefixes from each one of them, and approximately all demos took maybe 5 to 10 minutes, something like that, maybe even less. So, by the way, on the screen at the moment, you can see our emails. And I want to thank especially Melchior, most of these folks he brought together, and it was great effort. Melchior, I think you want to add something. Actually, before we closing, from each one of you, very short, we can take, what's your suggestion? Maybe we can start with this presentation here, name Melchior, you can start, Alex, etc. We can continue like this.
Yeah, so first of all, I want to thank everyone who participated. Really awesome that we were able to bring this much people together in such short notice and actually do this live. It was really cool. So my takeaway would be, I hope we were able to show you how easy it is to configure RPKI, set up ROAs or create ROAs and set up validators. If you have any questions, please do reach out. I think that goes for everyone. We're all very excited about this and willing to help you with whatever questions you might have.
Also, you want to thank someone, I remember.
Yeah, that's the next slide. Florian, if you want to put the next slide up. So here's the additional resources. If you want to read about the configuration we use today, there's a link to the Google Docs. And there's a few links which are really interesting if you want to read more or want to start deploying RPKI yourself. There's a few folks I want to thank in particular, Nicole Weyer, Edwin Verwoerd, Job Snijders, and Max Tucci. And there's one company I want to thank, that is i3d.net, who sponsored the server and the full transit in order to make this demo possible. So thank you very much for your help.
Okay, can we go back to previous slide, please? And I think next, Alex, what you would say? What's your takeaway?
My takeaway is that basically we've shown how easy it is to install validators and how easy it is to set up a connection to a validator and start validating and dropping invalids. What I would like to urge people to do is, once they start creating ROAs, to maintain them. Maintain your ROAs. Make sure that they are updated. Once you start creating ROAs, more and more people start dropping invalids. So you can lose connectivity if you don't maintain your ROAs. Please do it.
Thank you, Alex. Also, I think my turn. Have a look at MARNs as well, mutually agreed norms, definitely. And they are all aware, they helped also for this webinar to be happening. We have, because there you can see lots of filters, etc. We talked today origin validation and RPKI specifically. We talked also, I talked with Jeff Tanstra and Melchior on specific pet security, pet validation aspect, ASCON draft actually. And we have other videos also on YouTube channel, but you can follow me on LinkedIn. I'm using Orhan Ergun, please add me there. So you can follow up all our updates. Jeff and Melchior, we are producing some videos. Also, we have other like Alexander Asimov, ASPA draft, BGPsec, lots of things. So I want to produce more and more this kind of videos, not only RPKI but also BGP, other security side, pet validation, etc. Please follow up by connecting with me on LinkedIn or Ergun. That's it. So, Greg, what's your takeaway? What you would suggest?
I just wanted to add my thanks to everyone. I mean, this literally came together in a couple hours, so I think it was great that all the live demos worked. I would just urge everyone to go and look into RPKI deployment. There have been several presentations over the past year or so by large providers analyzing the impact of dropping invalids, and the general conclusion is that there's no impact. So as we said earlier, there's no reason to accept invalid information into your routing table, and you should just start dropping it.
Good suggestion. Invalid reject in the beginning we said, but some people we are seeing also, maybe even transit operators, probably they will transition to invalid reject policy, but let's see, hopefully. Jacob.
Yeah, hi. Thanks for Jeff for inviting me, and Melchior in particular for the support you've given me with this demo. I would say to people who want to implement RPKI that in Cisco on XE and XR, we've had it for many years, in fact. And I think I think probably the hardest part is do not invalidate your downstreams. So if you sub-allocate your prefixes, make sure that you that your ROA does not invalidate your sub-allocated prefixes, so that your downstream can issue their own ROAs. And that even if your downstream does not issue their own ROAs, make sure you do not invalidate them anyway. That and the max length helps with that. Actually, no, it doesn't. No. Your downstreams have to sign the ROAs. Otherwise, your ROA will invalidate it.
Yeah. Okay. Thank you for that.
That's that.
Next, Florian.
Thanks, Orhan. Yeah, I mean, I want to thank everyone bringing all the people together here. I mean, it shows great effort. It shows what the community can do. Bug your peers if they don't sign their prefixes. Make the internet more secure and drop invalids. And therefore, I'm actually handing over to Tees.
Yeah, it was a really awesome demo, I think, and I really hope that we could show you all that this is not as hard as you may think it is. It's not that scary. You can configure it. There's real proper documentation that we collected while doing this, and yeah, it was an awesome effort. Thanks, Melchior.
Luis.
Just want to say thanks. Thanks for inviting. Thanks for organizing. I don't have much else to add, but that community is great, and there's a lot of things that have been done in the last 2 years. Now, like 2 days ago, was Hurricane Electric deployed RPKI. I mean, now we have almost like the biggest transit providers. The amount of RPKI invalids has dramatically lowered. So yeah, thank you. RPKI is even easier to deploy these days than ever. So
yeah, and hopefully we can see even more, and I'm positive on that. We will see even more operators will deploy this, and hopefully we can help a little bit maybe this video. And Jeff.
So number one, I would like to thank you, Vinay, and we forgot to put his name on the slides. It's going to be updated just after we finish. So nothing makes me happy than seeing community coming together and solving common issues, right? That's what we do in ATF, and RPKI came from ATF. So there's absolutely no reason for you not to do this. It's not a rocket science anymore. You don't need to be a wizard to do this. You've seen how easy it is to configure on routers. The installation of validators is straightforward. So I would say just go and do it. There's absolutely no excuse or reason not to. And thanks everybody for coming together. Probably within the last 2-3 days, everything was organized. It's pretty amazing. And thank you, everyone. That was completely amazing. the work of a team and how fast and how great we did it, or you did it actually.
It was really great effort. And Nathalie.
Nothing to add here. I think this was a really good example of how the community works. Set up your ROAs and enjoy your weekend.
Yes.
Deploy your RPKI. It's not hard really. And thanks everyone. Bye.
Thank you. Bye-bye. And deploy RPKI.
Bye.